Hi students, good evening. Today we are going to discuss about the dimensional analysis. So, first we will discuss the dimensions of the physical quantities. Okay, this word dimensions do we use in our everyday life or not? For example, every day we are using so many objects. So, for example, I have considered three objects. This is a thin wire. The first one is a thin wire. Its thickness is negligible comparing to its length. So I will say that this thin wire is having only length. There is no breadth, height or volume or area. So I can say that this object, namely the thin wire, is having one dimension. So it is a one-dimensional object. Now you consider this is a rectangular plate. So that the longer side, okay, is L and the shorter side is B. So this rectangular plate is having a length as well as breadth. So it is considered to have two dimensions. So this rectangular plate is a two-dimensional object. It has an area. Like that you consider a cuboid, a brick-shaped object, rectangular parallelepiped or cuboid. So it is having a length, breadth and also height. So how many dimensions this cuboid is having? 3 dimensions. So the brick-shaped cuboid or parallelepiped is a 3-dimensional object. Like that, when objects are having dimensions, similar to that, the physical quantities which we are going to study in physics also have some dimensions. Say speed, velocity, acceleration, force, all these are having some dimensions in mass, some dimensions in length, time and all. Now, we are studying the SI system of unit. We are following the SI system of a unit. Okay, the international system of unit is called as SI unit. In SI unit, there are 7 fundamental quantities. So, I am going to write the 7 fundamental quantities, okay, in the SI unit and the dimensions. So, what is the physical quantity? I will write on the left hand side. So the physical quantity, and each physical quantity is having some dimensions. Okay, the dimensions of the physical quantity. So what are the 7 fundamental physical quantities? Number 1 is length. Okay, I will take length. Number 2 is mass. Number 3 is time. So length, mass and time are called the mechanical quantities used in mechanics. And electrical quantity is electric current. Okay, so the next one is electric current. Okay, then in thermodynamics we use temperature, absolute temperature. So the temperature, it's called absolute temperature. It is to be expressed in Kelvin scale. And the 6th one in optics, luminous intensity. Luminous intensity. So this is luminous intensity. And lastly, amount of the substance. So amount of substance. So these are the 7 fundamental physical quantities in the SI system. Okay, now what are the dimensions allotted for each fundamental quantity? That must be represented in square bracket. Say length is having a dimension denoted by capital L, and this must be this must be written in the square bracket. Okay, mass. So mass is having a dimension capital M within the square bracket. Time. So the dimension of time is capital T, and that is also to be written in the square bracket. Okay, electric current, the unit is ampere and the symbol is capital A, that is also the dimension. Okay, capital A is the dimension of this electric current. And temperature, what is the SI unit of temperature? Kelvin. It is named after Lord Kelvin. So K is the symbol and also K is the dimension for this temperature. Okay. And now luminous intensity. It is the amount of light energy radiated per unit area per second. Energy per unit area per unit time. And its unit is candela. So this luminous intensity is having a dimension represented by the symbol small c and small d. This is also the short form, the symbol for candela, which is a unit of luminous intensity. And lastly, the amount of the substance is expressed in mole. So we have studied 1 mole of any substance contains what Avogadro number of the atoms, is it not? Or molecules, 6.023 into 10 power 23. So that is the mole. So the short form of mole is the dimension, namely MOL within the square bracket. So this is the way first we have to learn each physical quantity is having some dimensions. So the dimension of length is capital L, the dimension of mass is capital M, the dimension of time is capital T. These three are the dimensions of the mechanical quantities used in mechanics. And the dimension of electric current is capital A. The dimension of temperature is capital K. And the dimension of luminous intensity is small c d, small d. And amount of the substance is MOL, mole. Okay. Now for example, let us take, for example, I will take speed. Okay. One physical quantity, I will take speed. How do you define speed? Speed is equal to what? Distance traveled divided by time. Distance traveled per unit time. So I will write this is equal to distance, okay, distance divided by time. And distance is what? How will you define distance again? It is the actual length of the path, is it not? Length of the path. So what should be the dimension for distance? It is equal to the dimension of length only. So I will write distance is capital L divided by the time is having a dimension of t. So this is L divided by t. So that this can be written as capital L t power minus 1. From the denominator, t is brought to the numerator. So it becomes t power minus 1. Okay, I will put this inside the square bracket, and this is the dimensional formula. This is called the dimensional formula or the dimensions of speed. Okay, what do you mean by writing L power 1? This L is nothing but L power 1. I say that speed is having one dimension in length and it is having minus one dimension in time. Does it depend on the mass of the body here? Is there any mass term here? No. That means that the speed does not depend on the mass. Shall I also say that it has zero dimension in mass? Why? Because in mechanics particularly, though the term depends on the length, mass or time, all the three must be expressed in the square bracket. That is the rule. That is why I am going to write the same as this is m raised to the power 0, L raised to the power 1 and t raised to the power minus 1. So this m power 0, L power 1, t power minus 1 is called the dimensional formula of speed. So you must remember, speed has 0 dimension in mass, 1 dimension in length and minus 1 dimension in time period. Like that, now I am going to derive some of the dimensional formula of the physical quantities in the next video. Until then, bye.